Hey everyone, in this video I will be going over the substitution method for solving systems of linear equations. Our learning target is I can solve a system of two linear equations using the substitution method. So to solve a system of linear equations using the substitution method, the golden rule is one of the variables must be isolated on one side of the equal sign. By doing this, it allows us to substitute an expression in for a variable in the other equation. This may sound complicated right now, so let's just start looking at some examples. So I'll be taking a look at this system on the right here. Okay, I've got y equals 2x minus 3 and y equals 6x plus 1. So this system tells us that y equals 2x minus 3 and 6x plus 1, because remember, this system is going to have the same ordered pair as a solution. So the first question we must ask ourselves when solving a system using the substitution method is there a variable that is isolated? The answer to this, of course, is yes. Y is isolated on one side of the equal sign in both equations. So if we take a look at the top one, y is all by itself. It's isolated. That's a good thing. And for the bottom one, y is isolated. That's very good. So typically we'd just be looking for one isolated variable, either this y, this x, or this x. Here we have two isolated variables, and we're not going to complain about it, okay? We have what we want so far. So let's go down to the problem-solving process. Okay, so because the y is isolated in both equations, we have the option of choosing the expression 2x minus 3 or 6x plus 1 and plugging that in for y in the other equation. So if I take a look at this right here, I'm going to look at y equals 6x plus 1. Okay, this equal sign in math, equals means is. Okay, so this basically is saying y is the same thing as 6x plus 1. So that means I can take this 6x plus 1 and replace the y up top with the 6x plus 1, because I know they're equivalent. Okay, so if I rewrite this top equation, I have 6x plus 1 and then the rest of my equation, so equals 2x minus 3. So what I'm going to do, I'm going to take this equation now and solve for x. So I've got 6x plus 1 equals 2x minus 3. And now I'm just going to solve. Okay, so in order to do that, I'll get all my x's on one side and all my numbers on the other. So I'll subtract 2x, cancel the 2x's out on the right side. And then I can subtract 1 from both sides to cancel the numbers out on this side. So if I simplify this, 6x minus 2x is going to be 4x. And negative 3 minus 1 is going to be negative 4. Okay, so if I continue to solve here to get this x by itself, I have to divide by 4 on both sides. So x is going to be negative 4 divided by 4, which of course is negative 1. So there we go. We have one coordinate for our solution here. Okay, we have our x coordinate. Okay, so now that we know what x is, we need to find y. Okay, so we're going to pick one of our original equations, and it doesn't matter which one, you should get the same answer, and plug the x value in for x to solve for y. So let's do the bottom. So I'm taking the original bottom equation, which was y equals 6x plus 1, and what I'm going to do is I'm just going to replace this x with the negative 1 that I just found. So I have y equals 6. Instead of x, I have negative 1, because it is no longer an unknown, and then the rest of my equation plus 1. Okay, so if I simplify this, I have y equals 6 times negative 1 is going to be negative 6. And then this plus 1 just joins the party. And negative 6 plus 1 is negative 5. So at this point, I have an x-coordinate, I have a y-coordinate, so I can plug my solution down in parentheses. Negative 1 for x, negative 5 for y. So that means if I took this original system, the y equals 2x minus 3 and the y equals 6x plus 1, and I were to have graphed them, they would cross at the point negative 1, negative 5. So just another way or another method of solving a system of linear equations. Okay. So, taking a look at this system, negative 7x plus 3y equals negative 4, and y equals negative 4x plus 5. We notice that the y is isolated in the bottom equation. We just have one variable isolated this time. But that's good. That means we're not going to have to do a ton of algebra before we get going. We don't have to isolate a variable by ourselves. So, because this y is isolated, I know that y is negative 4x plus 5. So I can take this negative 4x plus 5 and put it in place of the y in the top equation. I can substitute that expression in. So when I do that, I have negative 7x plus 3. Instead of y now, I'm going to have that bottom expression, so negative 4x plus 5 equals negative 4. So I just rewrote my top equation, but instead of plugging in y, I replaced it with this negative 4x plus 5. So what I'll do now is I'll rewrite this equation down below and solve for x. So my first step when solving for x here, I need to get rid of the parentheses, so I will distribute this 3, which means I'll be multiplying. So I end up getting negative 7x. 3 times negative 4x is going to be negative 12x. And 3 times 5 is going to be positive 15. And then the equals negative 4. If I continue to simplify, negative 7x minus 12x is going to be negative 19x, followed by the rest of my equation. So now what I can do is I can subtract this 15. So now I have all my x's on the left side and all my numbers on the right side. So once I do that, I have negative 19x equals negative 4 minus 15, which is negative 19. Now to get that x by itself, my last step here is going to be to divide by negative 19 on both sides. Negative 19s cancel on the left side, so x is isolated. So I end up getting, go over here a little bit, x equals negative 19 divided by negative 19, which is going to be 1. So I have my x-coordinate. Now it's time to solve for my y-coordinate. Oops. Okay, so I need to pick the top or bottom equation. I'm going to pick the bottom one again because I'm going to have one less step because the variable is isolated, or the y is isolated. So my bottom equation, just as a reminder, is going to be y equals negative 4x plus 5. But instead of this x here, x is no longer an unknown. I know what it is. So I am going to rewrite this equation as y equals negative 4. But instead of x, I'll be plugging in positive 1 that I just found, and then plus 5. If I continue to simplify, negative 4 times 1 is going to be negative 4. And negative 4 plus 5 is going to be positive 1. So for this system of equations, use the substitution method. I got 1 for x. When I plugged that in, I got 1 for y. So if I were to graph these two lines, they would cross at the point 1, 1. Okay, here we have a little bit more complicated system. Not too complicated, but just a potential extra step that we need to look at. So what is different from this system of equations compared to the previous two? So I have x minus y equals negative 3, and I have negative x plus 6y equals 18. Okay, so it looks a little different because none of the variables are isolated. Okay, so on the left side of the equation, we've got both the x and the y. And then for our bottom equation, we've got the x, we've got the y, we've got a negative sign, and we've got a positive 6. Okay, so none of our variables are isolated. Therefore, our first step is going to be isolating one of the variables. So isolate either x or y in one of the equations. Okay, and it just needs to be one variable. It's not like we have to take y in the top equation and isolate it and y in the bottom. We're not doing that. Just picking one of the variables and isolating. So it doesn't matter which variable or equation we pick. It does not. We should get the same answer regardless of which variable or equation we pick. Okay, and then I have this little speech bubble down here that says, though it does not matter whether we pick x or y in the first or second equation, the problem will be easier on us if we pick a variable that does not have a coefficient. Okay, and a coefficient just being a number attached to the front of it. By doing so, we will not have to divide when isolating the variable, which means we will be avoiding any fractions. So what that means is if I take a look at this bottom equation here, This y, let's say I choose to isolate that, this y has a coefficient of 6. So that means when I'm trying to isolate this y, I would add x on both sides, but then I would have to divide everything by 6. Okay? And because I have to divide everything by 6, I'm turning one or more of the terms on the right side now into a fraction. Okay? And though we are well equipped to solve problems dealing with fractions, if we can avoid them, most people would. Okay? I know I certainly would avoid fractions if I could. So just be careful what you're picking. Make sure you're trying to pick a variable that has no coefficient. Therefore, we're not going to have to divide, which dividing always gives us the chance of having a fraction. So if you're not a big fraction person, try to pick a reasonable or a reasonable variable that doesn't have a coefficient. Okay, but let's say you do happen to have fractions in your expression that you are substituting in. That's not a big deal. Okay? You are allowed to have fractions and you should get the same answer. It's just all personal preference whether you want to be dealing with them or not. Okay. So our first step, we need to isolate either the x or y in the top or bottom equation. Okay, and it looks like x or y in the top equation as well as x in the bottom equation will allow us to proceed without fractions. Okay, so how about we do the top? Okay, and if I rewrite the top equation, it's going to be x minus y equals -3. Okay, so I'm going to get this x by itself. I know if I try to get this y by itself, I'm going to have to divide by -1, which won't leave me with any fractions, but it is an extra added step. So for the sake of time, let's try to get this x by itself because we're not going to have to divide by anything at the end. It already has a coefficient of +1. So to get the x by itself, I'll add y on both sides. When I do that, the y's cancel, and I'm left with x equals -3 plus y. If you had y minus 3, that's the same thing. You should get the same answer. Don't worry about it. Okay. So there, I have the x isolated. I'm good to go. I can proceed with my substitution. All right, so what I'll do now is I'll take my bottom equation. My bottom equation is going to be -x plus 6y equals 18. But now I know what x is. Okay, I have an expression that is equal to x. So what I can do is I can replace that x with that expression that I just found. So if I rewrite this bottom equation, I've got -3 plus y, which is replacing the x, and then the rest of this equation. So I've got plus 6y equals 18. Okay, so I'll go down here and I will rewrite this equation. So I've got negative, parentheses, -3 plus y plus 6y equals 18. So if I'm solving for y, my first step is going to be to get rid of the parentheses, so get rid of this negative sign. Remember, this negative sign out in front is the same thing as having a -1 in front. So if I multiply here, I've got -1 times -3, which is going to be a +3. -1 times y is going to be a -y. And then the plus 6y equals 18. If I continue to solve, -y plus 6y, that's going to be -5 or +5y. and then I'll bring down everything else. So I've got this 3 equals 18. I will subtract 3 on both sides to bring my numbers all over to the right side. So I end up getting 5y equals 18 minus 3, which is 15. So to get the y by itself, my last step would be to divide both sides by 5. That'll cancel the 5's on the left side. I go over here. I have my answer, which is y equals 15 divided by 5, which is going to be 3. Okay? So since we know what one of the variables is, and in this case we know what y is, we can plug what that variable is equal to into one of the original equations to solve for the other variable, which in this case will be x. So let's take my top equation, which again, as a reminder, was x minus y equals negative 3. And let's replace that y with 3, the value we just found. So I have x minus, instead of y I have 3, equals negative 3. Okay, so if I rewrite this without parentheses, x minus 3 equals negative 3. I can add 3 to both sides to isolate this x. When I do that, I get x equals negative 3 plus 3, which is 0. So I've got a value of 0 for x and 3 for y. So that would be my solution. So if I were to graph these two lines, they would cross at the point 0, 3. Okay, we are almost done with our actual notes before we take a look at some examples. But before we take a look at some examples, we have some special cases that we should discuss, some situations that you most definitely will run into at some point. Okay, so at this point, we know that we won't always have one solution. Okay, we've got two special cases where we will either have no solution or infinitely many solutions. So let's take a look what that will look like. So taking a look at this system here, I've got negative 6x minus y equals negative 2, and I have y equals negative 6x minus 7. I have a variable that's isolated, y in the bottom equation. So I'll take this expression, negative 6x minus 7, and substitute it in for y in the top equation. So when I do that, I'll rewrite my top equation. So negative 6x minus, instead of y, I've got the expression negative 6x minus 7 equals negative 2. So if I continue to solve and I get rid of those parentheses by distributing, I get negative 6x, negative 1 times negative 6x is going to be positive 6x. And negative 1 times negative 7 is going to be positive 7 equals this negative 2. If I continue to simplify, negative 6x plus 6x, the variable I'm solving for being x, cancels out. So when that happens, I'm left with positive 7 equals negative 2. So my whole goal is to solve for one of the variables, and all my variables canceled out. Okay, I've got no variable to solve for here. So if I take a look at this, let's take a look at 7 equals negative 2. First off, does that make any sense? Is that true or is that false? Okay, and clearly this is not true. This would be false because 7 is not negative 2. They are completely different numbers. So this would be false. Doesn't make sense. So if the final statement doesn't make sense, the solution to the system of equations is going to be no solution. And that is because these lines will never cross. And when two lines are never, ever going to cross, that means they are parallel. Okay, so in fact, if you were to take this top equation and try to put it into slope-intercept form, so get the y by itself, you would have two lines that have the same exact slope. And when two lines have the same exact slope, as we saw when we graphed systems of linear equations, we could tell that they were parallel, they were never going to cross, they were never going to cross. Our solution was going to be no solution. Now let's take a look at our other example. So I have y equals negative 2x plus 10 and 4x plus 2y equals 20. Okay, so I do have a variable that's isolated. I've got this y all by its lonesome up here in the top equation. So that means I can take this negative 2x plus 10 and I can substitute it in for y into the bottom equation, since I know y and negative 2x plus 10 are equivalent. They're the same thing. So if I do that, I'll rewrite my bottom equation. So I have 4x plus 2, but instead of y, I have negative 2x plus 10 equals 20. If I simplify, I have to distribute the 2 to everything inside the parentheses. So I get 4x minus 4x plus 20 equals 20. I continue to solve. 4x minus 4x, those are going to cancel. So I am left with 20 equals 20. So very similar to the last equation, I tried to solve for x, but I failed because my x's just canceled out. I've got nothing to solve for down here. Okay, so I'm going to evaluate this 20 equals 20. First off, is that true? Does that make sense? And yes, 20 does equal 20. That is true. Okay, and because that is true, it makes sense, our final statement here, that's what I call this, the final statement. And because it makes sense, our solution to this system of equations is going to be infinitely many solutions. Okay, and it's infinitely many solutions because these lines overlap. At every point. Okay, and when two lines overlap at every point, that means they are the same line. Okay, so that should be pretty much everything we need to know as far as note-taking goes. So at this point, if you don't need to see any example problems, you can move on or you can turn off the video. But for everyone else who would like to see a couple more example problems and continue to work at this, I am going to scroll down and go over some example problems. Okay, so let's take a look at this first one. So for the first one, got y equals 7x plus 11 and y equals 2x plus 6. Taking a look at this, I want to see if any of the variables are isolated. And in the top equation, we've got y isolated. In the bottom equation, we also have y isolated. So this would be very similar to the first example problem we did. So because I know y is 7x plus 11 and y is 2x plus 6, I can take this 2x plus 6 and I can substitute it in for y in the top equation. So when I do that, I'm going to have 2x plus 6 equals 7x plus 11. So just rewrote the top equation, but instead of y, I plugged in 2x plus 6. So if I go ahead and solve this, I can subtract 7x on both sides. When I do that, these 7x's cancel. 2x minus 7x is going to be negative 5x. And I'll bring everything else down. Plus 6 equals 11. So now I can subtract 6 on both sides. When I do that, 6 minus 6 is going to cancel. So I'm left with negative 5x equals 11 minus 6, which is 5. Can divide both sides by negative 5 to get the x by itself. They cancel. So I've got x equals 5 divided by negative 5, which is going to be negative 1. Okay, so now that I know what one of my variables is equal to, so I know x equals negative 1, I can pick either the top or bottom equation, replace the x or substitute negative 1 in for x, and solve for y. So how about I take my top equation? Again, it does not matter which one you pick. You will get the same answer if it has been done correctly. So I've got y equals 7. Instead of x, I now have negative 1 plus 11. Keep simplifying, I get y equals 7 times negative 1, which is negative 7, plus 11. And negative 7 plus 11 is going to be positive 4. So the solution to this system of equations is going to be the point negative 1, positive 4. Okay, so did all this math here, substituted an expression in for a variable, did the math, solved for x, then I took that x and plugged it into the top equation to get my y coordinate. Okay, and we're going to follow a similar process for the rest of these example problems. Okay, I will move on to number 2. Okay, for number 2, awfully similar. Both y's are isolated. So what I can do is I can take this negative 4x minus 13, and because I know that it is equal to y, I can replace the y up here with that expression. So when I do that, I've got negative 4x minus 13 equals 6x plus 7. So I can get my x's all on one side, so I will use a different color for that. I will subtract 6x on both sides to move my x's over to the left. X's cancel on the right side. Negative 4x minus 6x is going to be negative 10x. And then I'll bring down everything else. The minus 13 equals the positive 7. So when I do that, I can get my numbers to the right, so I can add 13 to both sides. 13's cancel on the left. So I end up getting negative 10x equals 7 plus 13, which is 20. To get the x by itself, I can divide both sides by negative 10. Negative 10s are going to cancel. So I am left with x equals negative 2. So now that I've solved for one variable, I have to solve for the other. So I need to take this negative 2 and plug it in for x in either the top or the bottom equation. So how about I do the top? So I'll go way up here. My top equation is going to be y equals 6. Instead of x, I'll replace it or substitute in a negative 2 plus 7. So 6 times negative 2 is going to be negative 12 plus 7. Negative 12 plus 7 is going to be negative 5, so I end up getting y equals negative 5. So I've solved for both variables, which means these two lines are going to cross at the point negative 2, negative 5. Okay, I will go down to number 3. So taking a look at number 3, these would be like the second example problems that we did on our notes, okay, where only one of our variables is isolated, which is totally okay. All we need is one variable isolated. So because one of our variables is isolated, which is y in the top equation, I can take this 5x plus 8 and I can substitute it in for y in the bottom equation. So when I do that, if I rewrite my bottom equation, I've got 5x minus, instead of y, I now have this expression, 5x plus 8 equals negative 8. So if I simplify, I will distribute this negative sign to get rid of the parentheses. So when I do that, I get 5x minus 5x minus 8 equals negative 8. I'll combine x's on the left side, 5x minus 5x. They're going to cancel out. So I end up with negative 8 equals negative 8. This will be one of our special cases. So first off, let's take a look at this. Does negative 8 equal negative 8? Does that make sense? And of course, negative 8 and negative 8 are the same numbers, so this is true. So because this is true, our final statement here is true and we've run out of variables, or canceled out all our variables, we're not going to have a coordinate as our solution. Our solution is going to be infinitely many solutions. Okay. In fact, these are the same exact line, just in different forms. This top one's in slope-intercept form, this bottom one's in standard form. So if we get true, it's going to be infinitely many solutions. If we get false, it's going to be no solutions. Onward to number 4. Okay, similar looking problem where we've got one variable isolated, and it is the y in the top equation. So that means I can take this negative 2x plus 9. Since I know y is negative 2x plus 9, I can plug it in for y in the bottom equation. So if I do that, I'll rewrite my bottom equation. So 5x minus 4, but instead of y, I've got negative 2x plus 9 equals negative 10. So to get rid of the parentheses, I will distribute this negative 4 because it is touching the parentheses. And when I do that, I get 5x plus 8x minus 36 equals negative 10. So we're almost there. 5x plus 8x is going to be 13x minus 36 equals negative 10. To get rid of the negative 36, I will add 36 to both sides. When I do that, negative 36 plus 36 is going to cancel. So I get 13x equals negative 10 plus 36, which is going to be a positive 26. To get this x by itself, I'll divide both sides by 13. 13s will cancel on the left side. So we are left with x equals 26 divided by 13, and 13 goes into 26 twice, so our answer is going to be 2. So because we know what our x coordinate is going to be, we can go up here and plug 2 in for x in either the top or bottom equation. I'm going to do the top because the y is already isolated. I'm not going to have to move things around like I would with the bottom equation. So for the top equation, I have y equals negative 2, but instead of x, I'm plugging in a positive 2, plus 9. Okay, so I have y equals negative 2 times 2, which is going to be negative 4. Then bring down the plus 9. And negative 4 plus 9 is going to be a positive 5, so I'll get y equals 5. So these two lines are going to cross at the point 2, 5. Okay, we are halfway through our examples, still chugging along. We'll head down to number 5. So number 5 is similar to one of the last example problems we would have done as part of our notes, okay, where none of the variables are isolated. So because none of the variables are isolated, what we need to do is isolate a variable. So I'm looking for a coefficient of 1 or negative 1 because that means that I will be dealing with whole numbers or integers as I'm going through this process instead of fractions. Okay, so this y has a coefficient of 8, coefficient of 7, coefficient of 6. So my best bet will be to isolate this x, get that x all by itself. So to do that, let me rewrite the equation over here. So to get that x by itself, I will subtract 8y on both sides. Eight y minus 8y cancels. So I get x equals 15 minus 8y. Or if you had negative 8y plus 15, it's the same thing. So now that I've isolated my x, I can take the expression that x is equal to and go ahead and plug it in for x into my bottom equation. So if I rewrite my bottom equation now, I've got 7, but instead of x, it's being replaced by 15 minus 8y. Substitute that in. Plus 6y equals 5. To get rid of the parentheses, I will distribute. When I distribute, 7 times 15 is going to be a 105. 7 times negative 8y is going to be negative 56y. Then I'll bring down everything else, the plus 6y and the 5. If I combine, negative 56y plus 6y is going to be a negative 50y. I'll bring everything else down. I've got this equals 5, and I've got this 105. At this point, it is time to get rid of this 105, so I'll subtract 105 on both sides in order to try to get that y by itself. So when I do that, 105 minus 105 is going to cancel. So I'm left with negative 50y equals 5 minus 105, which is going to be a negative 100. Divide everything by negative 50. Negative 50 divided by negative 50 is going to cancel. So I'm left with y on the left side. And it's going to look like a positive 2 because negative 100 divided by negative 50 is going to be positive 2 on the right side. Okay, so I've solved for my y. What I am going to do now is I need to pick either my top or bottom equation. You could also use this manipulated equation over here if you would like. Okay, it doesn't matter. We've got three options. All should give us the same answer. So I am going to choose the top equation. And I am plugging this 2 in for y in the top equation. So I've got x plus 8. Instead of y, I have 2 equals 15. 8 times 2 is 16, so I've got x plus 16 equals 15. I will subtract 16 from both sides. When I do that, 16 minus 16 cancels, so I get x equals 15 minus 16, which is negative 1. So my solution to this system of equations where these two lines would cross is at the point negative 1, positive 2. Got a negative 1 for x, positive 2 for y. Moving along, head over to number 6. So for number 6, very similar to number 5, I need to pick a variable in either the top or bottom equation, so x or y, and get it by itself, try to isolate it. So taking a look at my coefficients here, this x has a coefficient of positive 1, so that's a good candidate as a variable to get by itself. So I will rewrite the top equation. And to get that x by itself, I can subtract 2y on both sides. Two y's are going to cancel. So I get x equals 1 minus 2y. So because I have the x isolated, I've got it equal to an expression. I can take this 1 minus 2y and plug it in for x in the bottom equation. So when I do that, I get 2, but instead of x, I have 1 minus 2y substituted in, followed by the rest of the equation. Plus 4y equals negative 2. I will distribute to get rid of parentheses. When I do that, 2 times 1 is 2. 2 times negative 2y is negative 4y. And then the rest of my equation, plus 4y equals negative 2. If I combine like terms on the left side, negative 4y plus 4y will cancel. So I end up with 2 on the left side equals negative 2 on the right side. So if I take a look at this, I've run out of variables. I've eliminated everything. They've canceled out. So I know this is a special case. So first off, does 2 equal negative 2? No, it does not. This is false. This does not make sense. 1 is positive, 1 is negative. Therefore, because one of them is positive and one of them is negative, or they're just not the same number, it's not going to make sense. I'm not going to have a coordinate. My solution is going to be no solution. Moving on to number 7. So for number 7, occasionally we're going to have a problem like this where we're going to take a look at our variables, none of them being isolated, of course, and we're going to try to find the coordinate that, or the variable that has a coefficient of 1 or negative 1. And sometimes it's just not going to happen, okay? If this ever happens, I suggest trying to find an equation where one variable goes into the other two terms, okay, or one coefficient goes into the other two coefficients. So if I take a look at this bottom equation, for example, okay, 4 does not go into negative 7, and 4 does not go into negative 18. Therefore, if I try to isolate this x, I will definitely be dealing with fractions. Okay? If I take a look at this top equation, 6 doesn't go into 2, so that will leave me with a fraction. But 2 goes into negative 6, and 2 goes into negative 24. So if I try to get this x by itself, I will not be dealing with a fraction. So that seems like my best candidate. So I will rewrite the equation. I will add 6y to both sides. When I do that, negative 6y plus 6y cancels out. So I get 2, let me do that in black, 2x equals negative 24 plus 6y. Or if you had 6y minus 24, it's the same thing. I will divide everything by 2. 2's cancel on the left. So I end up with x equals negative 24 divided by 2 is negative 12. And 6 divided by 2 is going to be a positive 3y. So I can take this negative 12 plus 3y and substitute it in for x in the bottom equation. So let's go ahead and do that. I have 4, but instead of x, I have negative 12 plus 3y. Minus 7y equals negative 18. Distribute the 4 to get rid of the parentheses. So I get negative 48 plus 12y minus 7y equals negative 18. If I continue to simplify, I'll combine like terms on the left side. So I get negative 48, 12y minus 7y is going to be positive 5y equals this negative 18, which I still haven't touched. Now I can add 48 to both sides. When I do that, 48s are going to cancel. So I'm left with 5y on the left side equals negative 18 plus 48 on the right side. So negative 18 plus 48 is going to be a positive 30. At this point, I can divide everything by 5 to get that y by itself. So I end up with y equals 30 divided by 5, which of course is 6. Okay, so quite a bit of work there. We are almost done. Our next step is we need to take this 6 and plug it in for y in either the top or bottom equation. And to switch it up, let's do the bottom this time. Of course, it doesn't matter which one you pick. So my bottom equation is 4x minus 7, but instead of y, I know I can replace it with a 6, equals negative 18. If I simplify, I get 4x, negative 7 times 6 is going to be negative 42, equals negative 18. All right, I will add 42 on both sides. Negative 42 plus 42 is going to cancel out. Okay, and then I've got negative 18 plus 42. So I've got 4x on the left side, and I've got negative 18 plus 42 on the right side, which is going to be a positive 24. I can divide both sides by 4. When I do that, 4's are going to cancel, so I end up with x equals 6. So the solution to this system of equations, where they cross, is going to be the point 6, 6. Last one, then I'll stop talking, I promise. Well, I'll probably keep talking, but you won't have to listen to me. All right, so taking a look here at my coefficients, none of them are 1 or -1. So there's the potential I will be dealing with a fraction. If I take a look at my candidates here, -3 does not go into -4, so this will give me a fraction. -4 does not go into -3, so this will give me a fraction. Down below, -4 does not go into 3, so this will give me a fraction. And 3 does not go into -4, so that'll give me a fraction. So this is one of those scenarios where, no matter what we do, if we're going to use the substitution method, we're going to have to deal with fractions. Okay. So what I am going to do is I am going to get the y by itself in this top equation. Okay. Because even though they don't go into each other, I know this -4 goes into 8, so that's one less fraction I'll have to deal with. So if I rewrite this equation, I've got -3x minus 4y equals 8. If I get this -4y by itself, I need to add 3x. When I do that, 3x's cancel. So I'm left with -4y equals 8 plus 3x. I will divide everything by -4. -4's are going to cancel. So I get y equals 8 divided by -4, which is going to be -2. And then 3 divided by -4 is just going to be a -3 over 4x. So since I know y equals -2 minus 3 over 4x, that y is isolated, I can plug it in for y in the bottom equation, or substitute it in. So if I do that, I get -4x plus 3, but instead of y, I'm substituting in the -2 minus 3/4 x equals 19. I will distribute the 3. So I have -4x. 3 times -2 is going to be -6. 3 times -3/4 is going to be -9 over 4x. And then equals 19. So at this point, what I'm going to do, I've got my x's on my left side, but before I start trying to combine fractions, I'll take care of this 6, or this -6. So I will add 6 to both sides, just so I don't have it in the middle of my x terms there. So -6 plus 6 is going to cancel out. So I have -4, but I'm going to prepare this to combine this with my other x. So to add fractions, we need a common denominator. So I'll put it over 1 for now. And then I've got -9 over 4x. So -9 over 4x equals 19 plus 6, which is 25. Okay, so as I just said, we need a common denominator because we are subtracting fractions. My denominators currently are 1 and 4, so my common denominator is going to be 4. So I will multiply the top and the bottom by 4, just scaling that fraction. So if I do that, 4 times -4x, or 4 times -4 rather, is going to be -16. 4 times 1 is going to be 4, so I get -16 over 4x minus 9 over 4x equals 25. So when I'm subtracting these, I'm not going to change my denominator, just focus on my numerator. So -16 minus 9 is going to be -25 over 4x equals 25. To clear this fraction, multiply both sides by 4. 4's cancel on the left side. So I get -25x equals 25 times 4, which is 100. At this point, I can divide both sides by negative 25. Negative 25's cancel on the left side. And I end up with x equals 100 divided by negative 25 on the right side. So that is going to be negative 4. Okay? So now I need to pick either the top or bottom equation and plug negative 4 in for x. So I am going to do the top equation this time. So just so for continuity's sake, our journey continues up here. I like to put a lot of arrows so people can kind of follow the flow of my work. Okay, so if I do the top equation, I've got negative 3, but instead of x, plugging in negative 4, minus 4y equals 8. Negative 3 times negative 4 is going to be a positive 12. Then minus 4y equals 8. I will subtract 12 on both sides. When I do that, 12's cancel. So I get negative 4y equals 8 minus 12, which is negative 4. So I'll divide both sides by negative 4. Negative 4's cancel on the left, so I'm left with y equals negative 4 divided by negative 4, which is a positive 1. So my solution to this system of equations, after what seems like a whole lot of math, is negative 4, positive 1. So that's the end of our examples and the end of our video. As always, if you have any questions, comments, concerns, need more practice, please come see me. I would be more than happy to help you out. Have a great day, everyone.